what exactly is buoyancy? And why do things float or sink? Although this term might sound unfamiliar to you, we actually use this in our everyday lives. From carrying heavy containers over the vast ocean to sinking underwater and observing the deep ocean using submarines, we have used the property of buoyancy to master the seas and oceans. Buoyancy is the ability of an object to float on water or air. When an object floats, it is positively buoyant. When it sinks, it is negatively buoyant, and when it neither floats nor sinks, then it is neutrally buoyant. So heavier objects like iron or concrete are negatively buoyant, and lighter objects like a feather or a leaf are positively buoyant, right? Well, not exactly. The buoyancy of an object, believe it or not, does not depend on its own weight nor its density. It actually depends on the weight of the water and the amount that is displaced. An object can only float if the weight of the water that it has displaced is equal to the weight of the object. Check this out. Here I have 2 lumps of clay. Each of these weigh approximately the same. Now I will shape one into a boat and the other one into a ball and place each of them into this bowl of water. As you can see, the boat was able to float, but the lump of clay wasn't, even though they had the same weight. Why is this? This is because the shape of the boat on the bottom had a larger volume than the ball. Due to this, it was able to displace more water than the ball did. By displacing more water than the clay ball did without sinking as far, the amount of the water displaced was able to match the weight of the clay boat before it sank, allowing it to float. On the other hand, the smaller volume of the clay ball was not able to displace enough water to match its weight, making it sink. The shape of the object matters. Here's another demonstration. I'll place this orange into this bowl of water. Then I will mark where it has sunk to. Now I will cut a small portion of the top of the orange and place it in the bowl again. Observe how it now does not sink as much. This is because the orange is now lighter, and therefore it doesn't require much water to be displaced for it to float. This property doesn't just exist in water, it also exists in air. When there is an object lighter than the air it is displacing, it will float just like a balloon filled with helium or a hot air balloon. To further explore this awesome phenomena for ourselves, let's dive into our lab today. For today's lab, you will need a bowl of water, a straw, a pair of scissors, 2 paper clips, and a ruler. Using a ruler, measure about 3/4 of an inch from the end of the straw. Cut along this mark, then bend this piece of straw in half and stick each of the paper clips into each end of the straw like so. Now, drop the diver you made into the bowl of water and close the cap. Finally, repeatedly squeeze and release the water bottle to observe the diver floating up and down. So why did squeezing our bottle make our diver float? How does this relate to water displacement? Well, when we squeeze the bottle, it causes the pressure inside the water bottle to increase. Due to this, the water then pushes the air inside the straw, moving the air molecules closer and replaces the extra space with itself. Because less water has been displaced, the volume of water that has been displaced decreases, and therefore the diver sinks to the bottom. Now, you understand exactly why some small objects sink while other massive objects can float. You have also seen buoyancy in action with your own eyes through building your Cartesian diver. Now go out there and test other objects and test their buoyancy. Can you also try to shape them so that they float? What about having them sink? Keep exploring, and as always, happy sciencing!